Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 18th, 2025, about 4 days ago. The big hook is simple. This paper shows a best of n selector that beats majority voting by 4.61% and outperforms process reward models by 4.31% to 12.21%, while costing less at inference. The paper is titled TrajSelector, Harnessing Latent Representations for Efficient and Effective Best of N in Large Reasoning Model, and the implications for efficient test time scaling are quite significant. In short, the method reuses sampler hidden states with a tiny 0.6b verifier and trains end-to-end without step-level annotations, delivering a stronger accuracy to compute trade-off across multiple math benchmarks. Alright, the last part outlined the promise. Figure 1 shows how best of n works, from multiple drafts to one final choice. Best of n means sampling n independent reasoning paths and selecting the strongest candidate. The left side illustrates the question flowing into a generator that produces many solutions. The right side highlights the selection step, which compares candidates and picks one, so the final answer reflects the best available trajectory. Well, Figure 2 shows the best of n scaling curve, meaning accuracy improves as you sample more candidate solutions and pick the best. Best of n means generating many independent reasoning paths, then selecting one with a verifier. The red trajectory rises steadily and stays above majority voting in heavy process reward models, which signals a stronger accuracy to compute trade-off. The dotted upper bound marks the pass at n ceiling, and the gap narrows as n grows. Results summarize performance averaged across 5 benchmarks. So, Figure 3 presents the architecture that turns multiple drafts into one choice by scoring reasoning steps from hidden states. Hidden states are the internal signals a model produces while thinking, which reveal how confident it is. The left panel shows a frozen sampler generating trajectories and exposing the last hidden vector at each step. The top panel runs a tiny verifier that maps those vectors to wrong, neutral, or right scores. The right panel aggregates the step scores and selects the best response. Alright, Table 1 shows the head-to-head accuracy across 6 math benchmarks, and the selector consistently ranks near the top. Pass at n oracle marks the upper bound, meaning an ideal chooser that always picks a correct candidate when one exists. The selector averages about 59% at best of 32, which beats majority voting. At best of 16, it averages about 56%, again ahead of heavier process reward models. So Table 7 reports best of 32 results, showing the selector stays ahead of majority voting across 6 math sets. Pass at 32 oracle means an ideal chooser that always picks a correct candidate when one exists. With Q34B as the sampler, the average reaches about 59%. With Q314B as the sampler, the average climbs to about 68%. The consistent gains indicate the scoring method transfers across sampler sizes. Wrapping up, 2 takeaways stand out. Reusing hidden states with a tiny 0.6b verifier reliably picks stronger answers than majority voting in heavy process reward models, and the end-to-end training without step-level labels generalizes across n and model sizes. The broader implication is cheaper, scalable test time reasoning. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.